Hey folks, how you going today? We have something super interesting for you all. This is the CanMV K230. I don't know if you know about it, but this is the Kendryte K230 MCU and it is excellent. Why? Because it's got RVV 1.0.0 implemented. It's the, there we go, it's the C910 core, C908 core, which is the next one up from the C906 essentially, which only implemented the RISC-V vector extensions version 0.7.1, like everyone seemingly did. This though has version 1, which is meant to be a huge improvement. This is the only board that I know of that you can get that has RVV 1.0 running, and a huge thanks to Bruce Holt on Reddit for pointing that out. That guy is all over RISC-V and knows what he's talking about, so if you see a post or a comment from him, have a read, it's good stuff. There's nothing else out there like this that I can see though, and I can't wait for there to be more of it. So we're gonna have a look at this board. We're gonna talk about the giveaway from the last video and who won and what they're getting. But first of all, I just want to talk about PCBWay for you as well. They're going to sponsor this video, I hope. I haven't asked them, but they've been really good. Most of my stuff involves a PCB of some sort like this, or even you know, components and assembly and cases, and they do all of that. What I find really interesting though, because my other bits haven't arrived yet, they just shipped yesterday, I can't show them off, but that'll come soon, is that I saw another YouTuber, and it is really weird to consider myself a YouTuber, because I'm not. I'm a network engineer who also makes YouTube videos, but call it what you will. So I saw another bloke, did a video, and he's doing an ad read for another PCB mob, except he's going on about how they've now got flexible PCBs. And I'm thinking, I've seen that on PCBWay's website for a long time. So when they had a look, and check it out, they do it. They're very good at it. They've got PCB assembly, they've got part sourcing, they've got a module store. You can upload your project there to share it with others. They'll do 3D printing, but they've got flexible PCBs. It's not that big of a while. They do an excellent job at it, like everything else. Back to this. This is something else, and I'm not sure if you'll agree with me, but I agree with me, and that's what's important. Now, this they did have like a dev board. This is kind of their first actual release meant for consumption. So you've got a Pi 2 header, you've got your 2.4 gigahertz Wi-Fi chip there, you got your MCU, which hasn't gotten hot so far, a little camera interface built in, it comes with that, which is awesome, a WS2812 LED there, which is controllable via one of the GPOs. Hang on, I actually wrote that down in my phone. Where is that? That is GPO 35, you can control that with. You got S1 and S2 buttons there, which is GPOs 53 and 52. Over here, you've got two USB ports, and they're very important, but one's power and one's USB, of course. A reset button. You've got 3.5mm TRS there, LAN, full-size HDMI, and you can see you've got the connection there, or the controller for the LAN, which is bound to have some little magnetics in it. You've got the HDMI interface controller there, some RAM, and on the back, you have DSI, 2 CSI, and your SD card slot. There's a better picture for you. So this thing's got a lot of interfaces built into it, which is pretty sweet. The core itself is a dual core RISC-V, of course. It's got, the first core is a C908 at 1.6 gigahertz with FPU, VPU, and the RVV 1.0.0 extensions. The second core is 800 megahertz, and it doesn't have the FPU, VPU, or RVV. It's a simpler core. And they've done that in an interesting way that accommodates their software really well too. It's got 512 gig of RAM and pretty much everything except for 5 gigahertz Wi-Fi, which for my use case is fine. 2.4 gets through walls and doors and roofs better, and 5 gigahertz is just faster. It's becoming more ubiquitous. It's meant to be faster, but it is a higher frequency, which means it doesn't quite reach as far. 2.4 is what I run all my IoT stuff on, and that is changing over time, but you'll see that's pretty much stock standard. So, if you haven't already, do like and subscribe to this channel for more of this, because I'm going to start doing some really, really highly requested stuff. This wasn't requested in the slightest, and that blows my mind, but you clearly don't know what you're talking about, otherwise you would have all asked for this. Or you do, and I don't, and that's also more likely because there's more of you than there is of me. So, I got this for $150 from AliExpress. It didn't come with any casing or anything like that. It literally just came with the bag, and they threw in a USB-C cable for me, which was pretty sweet. Now, they give you a couple of images. If we have a look at the website, I might put a picture up here. You've got the essentially, there's heaps of images, but if you simplify it, you've got your standard Linux image, so they give you that in Debian and Ubuntu. You've then got a MicroPython image, which is like cut down, includes an SDK with or without their NN AI engine stuff to build your own nets. And then they've got the MicroPython version. So essentially you've got MicroPython, C, or Linux distribution. And they give you a few flavors of each with different variants. So we will quickly have a look at each of them. I'm not going to measure the power consumption just yet because I don't have the meter with me, but I'll put it in the description below so you can have a look. I'm assuming it's going to be quite good. And we'll have a look at how this works. There are some little gotchas, essentially. And Canon, who make this, if you want to stock it in Australia, I'll stock it in my store for you. Link below to my store where I've got the Milk-V products, I've got LuckFox products, storage cards, cables, accessories, all really cheap in Australia with free shipping over $25. So go check that out too. Yeah, like and subscribe, please and thank you. God, I'm tired, it's hot, let's move on. So, with the two cores, what they are seemingly trying to do, if you boot up to them, we'll see that you get a little bit of RAM in one, and then the other has all the RAM in the big core. So we'll go to the MicroPython one first. That's the SD card that I've got in there now. What I'm going to do is plug in the HDMI LAN, and we're going to put in two USB ports. So this first one is, I'll put it in that way because that's how I'd already configured the computer, is power, but that's also going to expose two serial interfaces. This next one is data, but with what we're going to do, does something a little bit different. So if we plug all those in, let's jump back over to the computer, and there is something they ship called CanMV IDE that I've just installed. Now, if you haven't installed it, install it. When you first install it, it's going to ask you if you want to install any resource updates, so hit yes on that. If you have a look in Device Manager, you're going to have these two. Now, the higher number is the core that you're typically going to be working with, but you can have a look at the other core as well, which is really neat. So here, if we restart these two putty sessions that I've got, and that is 115200 with no flow control, and then we hit the reset button on the board, you're going to see the two cores doing two different things. Or one of them you're probably not see doing very much. Oh, there you go. It's running a real-time operating system with just MicroPython. So you can there see it's booted very quickly and started the repl interface. The other core is actually still booting. It takes a hot minute. And it's kind of like, this is going to be the back end that executes all the code and actually has access to most of the RAM. This front end is just our basic mini Linux kernel. That font's a little bit big there, isn't it? There we go. That's using 19 meg of RAM out of 100 it's got allocated. And we can see it's got a Linux 5.10.4 kernel. Proc CPU info. There's your core with the T-head extensions as well, and it's just got a little bit of storage built in. It's actually a little bit interesting that it's it works in a funky way. As you can see, I'm not going to get into the technicalities of that now, but it does have your interfaces all working, and out the box it does do exactly what you want. So you've got that connected and you're wondering what's next. Well, that's when you jump into this IDE, which is based on OpenMV IDE. And you know what? It's pretty bloody sweet. So if we click on our little terminal down here, hit that connect button, that's what this second cable is doing. So that's the MicroPython interface is on that second USB port with this build, which is pretty sweet. And you can see now we've connected on Comp7, which is the next one that appeared, to that MicroPython interface. So have a look at this. They come with heaps of examples. And as I said, this is going to run on the core that's dedicated to MicroPython. So you've kind of got a proper implementation of what Milk-V is going to be doing and what some of the others are doing, where you've got a big and little design almost. And you can run your multi-threaded operating system on one and your real-time operating system on the other. So you can treat Linux as like a watchdog for whatever you're going to be doing on the other one. And I really like that. I think it's quite expensive for that use case, but this is a demonstration of everything it can do. So if we even just go and have a look at the AI demo and grab this face recognition, actually we won't grab that because we haven't actually taught it any faces. Let's grab our face detection one. And all we have to do is just hit go. That is literally it. So that's running. You can see over here, it's engaged some stuff. Now if we go to OBS, it's using this little camera and it's outputting via HDMI all through the code. It's not using a GUI or anything like that to output. We'll turn off those overhead lights so you can see a little better. It's not bad quality at all, and its low light is pretty decent. You can see my camera up there recording, and now if we get a smiling face, I don't have one of those, but I can Google them. It is meant to be recognizing faces. Did I run the wrong code? Those all look good. Let's try that again, because this did work. Oh, there we go. Maybe I was looking at the wrong spot. So that is fairly responsive, and the tracking is pretty on point. So it works. It works straight away, and that's excellent. You can see actually if we stop this and we do the face recognition, it again runs super quick. Everything works out the box, which is excellent. So this is going to take a longer minute to spin up because it's going to have to load all of the data. If we go back and give it some faces, whoop, that's a blank phone. It's trying, but it doesn't know them. If we did some training and actually gave it faces that it knows, it would do a lot better. So I'm really, really impressed with that. And what we can actually do is use some of the interfaces as well. So if we grab a new blank document and we just grab some code I prepared earlier, let's stop that current code from executing. Overwrite the built-in one and execute this. It's just showing the two button values. Now, if I'll turn that light back on so we've got a bit of light there, push one of them. Oh, there we go. S2 is pushed in. Let go. It's out. S1 pushed in. So you've got everything we need there to work with all the hardware, and the documentation actually, it's all over the shop. There's all your images, but the documentation does have some pretty good examples. And if you can't find it, the examples included in CanMV IDE are quite excellent. I'm really happy with that. Now, in this instance, if you start playing with Wi-Fi and it crashes and you reboot, the Wi-Fi is not going to work. All you do is you reboot a second time. I'm not sure why, but it's like it's saving something in the MicroPython environment that bricks the Wi-Fi for a hot minute. So you just need to reboot again for that. Next up, you have your C or C++ environment. So if we just pop out that SD card and pop that one straight in, you can hit reset, and you'll see we're going to get quite a different interface here. All of these also appear to use glibc, which is really good. So if you want to compile your own programs, it's going to be quite easy for you. You're not going to have to do anything funky. All right, so we've got to give this a minute. It's a fresh flash, so it's a little bit slower than usual. None of these auto-expand or anything like that, but you can use the rest of the SD card to stick files on, which I've done with the Debian one. If we jump in here with root, and you don't have to put the password in twice, you'll see it's set up very much the same. Hello, fly. Will you go away, please? And you've got much the same stuff going on. But you can see there's that ShareFS. And in there, we've got an app folder. And here you have some of the example or sample code compiled to an ELF binary. Now, if, which one did we have here? Yeah, I'm not going to show them off. They do the same thing. Yeah, I'm not sure exactly how that bit works because you've got to execute it on the other thing, but the documentation's there, and I'd rather use MicroPython anyway. If anyone knows what the command is to launch it on the right core or make that code work, let me know, because there's something that you're actually supposed to do for it, and I forget. It's bound to be in there somewhere, but you get the idea. So you've got your MicroPython interface, you've got your C or your C++ interface, and then you've just got your general Debian image. So again, if we pop that one out and stick the Debian one in, this is actually a full Linux distribution. There is a caveat with it, so let's reboot this. We'll see it boot up into Debian now. It's all the same 5.10.4 kernel. They're all configured much the same, but you'll see where those two, the multi-thread OS only got 100 mega RAM, and the rest went to the second core, which is doing all the heavy lifting. this one gets all the RAM, because this is meant to turn it more into a usable device if you want to install Docker or anything like that on it. So you can see a full user environment booting up here. The only caveat I've found so far is that the Wi-Fi doesn't seem to work out the box. I'm not sure if that's just this release or what the go is there. Root and root to log in, but it doesn't come with any of the tools that you want for the Wi-Fi, from what I understand. And that's got me a little bit confused. I was going to try insmod bcmdhd. No, so that's the driver that it uses in the other environments. I'm really not sure what the go is here, but it doesn't seem to know what's going on. Even when I was having a look through dmessage, I wasn't really getting anything of any use. What's that core in there? That's an AP62. There's nothing there that looks hugely useful, so it's probably not enabled in the device tree. It could take just a little bit of messing around. Is there a config in here? It would probably be CanConfig or something like that. Yeah, I can't see anything that's going to give us that off the cuff, and it's so, you know, a little bit limited in what you can do, but whoop, you can see it's a proper operating system environment here. What you will want to do, if you haven't, is modify your etc app sources.list. The one it ships with is a broken repo, so just change it to deb.debian.org as the host name, and that'll work. I had to do that to install wget, and it worked a treat out of the box. Now, from here, you can do a fair bit. It doesn't actually come with a UI, but I'm assuming it knows about HDMI, so it would support it. It might be a bit laggy with only 512 meg of RAM though, so you'd want to use LightDM, XFC, something like that. Dmessage grep I HDMI. Alright, maybe not. Again, it's not designed as a computer that you're going to use as an everyday computer. It's designed as a a neural processing engine. It supports all of these models. It supports the latest RVV 1 spec. What we want to know though is RVV 1.0.0 actually hugely different? Is it going to make a difference to this? So we're going to run Geekbench, and I'll put the results up at the end. But I also want to thank Naveen Chowdhury. I'm not sure. I'm sorry if I massacred your name, mate. He put a comment in the last video for the $150 giveaway recommending the Beagle V Fire. So I'm going to order one, and that'll be the next video that I make if it arrives in time. Otherwise, it'll be the video afterwards. I'll leave a comment for him, and I'm going to post you all of that stuff, which has got a Milk V 256 meg, every accessory, cables, cameras, everything for you, even a little soldering iron. Have a look at the last video if you want to do more. I am going to do more videos, but this guy's suggestion has nearly 200 upvotes. The next one down has like 80 something. They're all good suggestions. I'm probably going to buy all of them, but congrats to him. Now, we need to run Geekbench. So for that, I'm going to mount this extra partition I made on this location I created, and in here we have Geekbench. So ChangeMart Y+X Geekbench RISC-V 64. I still say RISC-V, get over it. And then we'll let this run. So I'll keep this recording whilst it's running. We'll see how it does. We'll compare it to another single core performance that we've recorded to really see if RVV 1.0.0 is that much better than RVV 0.7.1. Bruce is probably sitting there shaking his head at me right now, but I don't care. I'm curious. And I think RISC-V is the way to go. An open ISA that everyone can contribute to, that there's heaps of variation on, that there's no licensing. Not only is it great for people like myself that love these emerging technologies and love things that are open source, but it's also great for competition. Competition spurs innovation. And we need more ISAs for these embedded low power systems that can be developed and built on, especially with AIoT, the AI of everything as it is now. That's more of what I'm going to be doing. This thing is bloody awesome. Thank you to PCBWay for sponsoring this video and providing me these great resources to keep going. Thank you to Bruce for telling me about this exact board. Much appreciated, mate. And thanks for all your work towards RISC-V. Oh, it isn't good. I'll have to do some tinkering with that. Jeez, out of memory. 512 meg is going to push it. I might have to try Geekbench 5. And thanks to you guys. Don't forget to like and subscribe if you want to see more of this stuff. I really appreciate it. I also have the second channel, which is all cooking, kitchenware and appliances. If you want to learn more about cast iron, cooking steaks, fried rice, plastic containers, everything like that. So I'm going to end this here, try to get Geekbench running, and I'll see you guys next time.